So 128 is all about solving inequalities. But before we can even solve an inequality, we need to understand that relationship and inequality represent. All right? We can order things based off of inequalities in particular. So we have symbols of relationships between numbers and objects. The first symbol is right here. This is called the less than. Oops. After less than, we have greater than. And the reason why is because we read from left to right. And the next one is called less than or equal to, greater than or equal to. All right, so we have these four little relationships. Of course, we have equal to. I could write that down too. But in particular, the first four are inequalities because they're not fully equal signs. The hard part that students struggle with, or not really hard, but students make a misconception of, is the less than or equal to and greater than or equal to symbol. This word or might not be what we think it means in English in particular. This means either less than, equal to, or I don't want to use or again. Both. The phrase less than or equal to means that you could be less than, you could be equal to, and you could be both. All right? As long as you satisfy one of those three, you are sufficient. So example, 8 is less than or equal to 8. This is true. We can also say 8 is less than or equal to 9. That is also true. But I cannot say something like 8 is less than 8. This is not true. Okay? So be careful on that. So these are the relationships we have. Now, let's take this example because we need to build some examples before we work with equations, inequalities in particular. So let's observe something real quick. Let's observe the equation 5 equals 5. This is clearly a true statement, right? This is true. This is true. True. Now, I told you guys if you do something to one side of the equation, you can always do it on the other side, or you have to do it on the other side to make it equal. So let's multiply this by -1 real quick. Do you think this is true? Well, if you said yes, then you are correct because this is -5 and -5. This still holds true. All right? Great. Now, let's work with inequalities in particular. What happens if I did 5 is less than 6? Right? If I add 1 to it, that becomes 6 is less than 7. That is still true. But observe. Right here. This becomes -5 is less than -6. Is that statement true? No, it is not. This is true, but this isn't. Not true. That's an issue. When we multiply by a negative, our results don't become true anymore. Why is that? Well, inequalities, the direction matters actually. When I had an equal sign, the equal sign is symmetric. It can go in either direction. It's symmetric. All right? If I cut it down evenly, you can fold it in half and it'll be the exact same thing. But inequalities, that is not true. So we have to make a note. Always change direction of inequalities when multiplying or dividing by a negative. When you multiply or divide both sides by a negative, you have to change the direction. All right? So let's see if that still works out. 5 less than 6. If I were to multiply that by -1 and change my direction now to -1 times 6, boom, boom, I get -5 is greater than -6. This is now true. Negative 6 is closer to negative infinity. All right, so it's smaller. So this holds. So this is a very powerful thing when we're solving inequalities. If we multiply or divide by a negative, we have to swap the directions. All right, so now we're going to cover 2 or 3 things in particular. First, let's just solve a regular quadratic inequality. We can do linear. You guys can do linear, but I'm assuming you guys can work with that in particular. So let's work with something a bit more complicated. X squared less than or equal to 5x minus 6. All right. Well, this is a bit weird. So over here, in this case, this is a quadratic. I like to set it equal to 0, so I want everything to move to one side. So I'm going to do that. I'm going to subtract 5x. Notice I'm subtracting, not dividing. I'm going to add 6 to both sides. So I do not need to change the direction. I have x squared minus 5x plus 6 is less than or equal to 0. I did not do any divisions or multiplication on negative. If I factor this guy out, this becomes x, let's see, minus 3, x minus 2. Okay, so we have this. Now, you might be inclined to say the solution is x is less than or equal to 3, x is less than or equal to 2. You have to verify this manually because you are not sure if one of them is negative, one of them is positive for the entire object. All right, you cannot see that. So, in particular, we know we have a solution. We know 3 is a solution, and 2 is a solution. Why do we know those are solutions? Well, if I plug in those values, I do get 0, and 0 is less than or equal to 0. So those are solutions in particular. So 2 is over here, and let's make 0 over here, and then 2 over here, and 3 over here. These are solutions in particular. Now, this tells you a lot of story. We know those points 2 and 3 are solutions. We have to check, is this a solution? Is this a solution? And is this a solution? We have to check 3 points. To the left of 2 are those solutions, and between 2 and 3 are those solutions, and past 3 are those solutions to the inequality. Well, let's check now. So how do I check? I choose a value. Choose a value to the left of 2. If x is equal to 0, then we have 0 minus 3 times 0 minus 2 less than or equal to 0. Negative 3 times negative 2. Remember, I'm not multiplying or dividing to both sides of the equation, so you're good to go. The inequality does not change direction unless I apply it to both sides. 6 is less than 0. Is this true? Yes or no? This is not true. So this fails. Fails. All right? Boom. Now I have to check a value between 2 and 3. Well, I'm going to do 2.5 in particular. So, if x is equal to 2.5, then we have 2.5 times 2. Oops. And all I'm doing is plugging in for x. 2.5 minus 2 less than or equal to 0. Is this a true statement? Well, if you look, 2.5 minus 3, that's going to give me a negative number, right? That's going to give me a negative number. So I'm just going to put negative, or you can write negative 0.5. You can also calculate out. And 2.5 minus 2, that's 0.5. If I multiply these out, a negative times a positive is a negative. I don't even need to calculate out. A negative is less than or equal to 0. This is a true statement. I think it's negative 0.25 or something like that. I don't know. But it's still less than 0, so this works. So this is true. This is good. All right. Now, what about past 3? Well, let's use the number 4. If x equals 4. If x is equal to 4, then 4 minus 3 times 4 minus 2. Is that going to be less than or equal to 0? My inequality in particular. 1 times 2. That's going to be 2 is less than or equal to 0. Is that true? No, it's not. 2 is not less than or equal to 0. So our solution is x belongs in only the middle portion. I include 2 because 0 is less than or equal to 0 in this case. So I start off with 2, brackets 2, because I want to include 2. And I go all the way. I'm counting in only the middle and stop at 3. and I include 3 because it's less than or equal to 0. If I plug in 3, I do get 0. Okay? So this is how you do one set of inequalities. All right, great. You have to check these regions just in case on your number line. Now, we work with the next topic, absolute value. All right? This symbol right here, absolute value, I think I gave a definition previously. I said that the absolute value of a value is always the positive value or the distance from 0 in particular. So we define this as x if x is positive and negative x if x is negative. All right, that's what it means. All right, that's the definition or whatnot. Not too big of a deal. How do we solve an equation out of it first? Let's not work with inequalities. Let's work with equations. Example. Let's see if we can figure this out. Boom. The absolute value of x is equal to 5. What does x have to be in this case? The absolute of what number gives me 5? Well, 5 works. The absolute value of 5 is 5, right? But the absolute value of negative 5 is also positive 5. So we say 5 and negative 5. All right, when we do the absolute value, you're always going to be splitting this up into the negative solution and the positive solution. All right, so here's how I'm going to show you the work in particular. I'm going to rewrite this. This is going to represent the positive solution. I just take away the absolute value. And to deal with the negative solution, I'm going to write the exact same thing, take away the absolute value, but on the right side of the equality, I'm going to multiply that by negative 1. And that's very important. Okay, that's how we can solve equations with absolute values. Now we can solve inequalities. So, how to solve inequalities? Well, we already know how to solve it. We have all the tools now. Now we just need to do it, actually. So, let's do an example. Let's do the absolute value of x minus 5 is greater than or equal to 8. All right. So, over here, this is not bad. I can solve this already. So, I know I have an absolute value. I'm going to split up to the positive solutions and the negative solutions. Boom, boom. So this is going to be x minus 5. It's greater than or equal to 8. And I have x minus 5 is greater than or equal to negative 1 times 8. But wait. I multiplied by negative 1. I multiplied by negative 1 here. This is very important. This was not in the equation or inequality initially. I brought it up randomly. Or not randomly, I brought it up because of the function in particular. So, if I do that, I need to change my direction. Boom. Only on the negative portion I change my direction, okay? Of the inequality. Now I can solve it out. I have x is greater than or equal to 13. I have x is less than or equal to negative 3. And then now I can plot this on a graph. This is the OR symbol. I really apologize for that, because it says x is greater than 13 and x is less than negative 3. So this is actually incorrect. I apologize. This is going to be x belongs in, x belongs in negative infinity, negative infinity all the way to negative 3, brackets, parentheses, union, brackets 13 to infinity. All right, so that's the OR symbol. I apologize, because they're not touching each other at all. They're going opposite ends. If I wanted to solve this, I'm going to split up into positive and the negative solutions in particular. All right, the positive one, you just take off the absolute value. Keep the exact same thing. That's all it is. Just take out the absolute value. The next one, you take out the absolute value, but you're going to multiply it by negative 1 to the right side, which means you got to flip the direction. And then you can solve it out. Negative 4, x is greater than negative 6. All right. So I have these two. Now, I want to graph it real quick to find out the solution. If I want to write this out, I have negative 4 here. I have negative 6 because negative 6 is a smaller number. I have 0 somewhere around here. I don't know. All right. These values I do not include at all because I don't have the equal to symbol. That means I should not want those values. So now it says x is greater than negative 6. So x is less than negative 4 and x is less than negative 6. So we have x belongs in. This is the and statement. X belongs in negative 6 to 4 parentheses. All right. So make sure you fix that up. And now, going with the last thing that we need to talk about is what if I had some crazier stuff? But before we even do that, let's actually formalize how we solve absolute values. How to solve. Isolate absolute value to one side. Side of the equation. Inequality. Always do this. You do not know how to work with it. Move everything away from it. You can keep everything inside the absolute value inequality, but everything outside better be on the other side of the inequality. Alright? So if I had a plus 6 to my inequality, or my absolute value, you better move that plus 6 to the other side. So isolate it first. Then after you isolate it, what you're going to need to do is break it up. Break into positive and negative solutions. Swap directions if multiplying or dividing by negative. Or dividing by negative to both sides. Let's say negative. Okay? Or negative. Alright. So these are the steps on how to solve an absolute value inequality. Absolute inequality. Now let's do an example of one that can get pretty messy. But if you keep track, you should be good to go. So I'm going to do negative 3 2x plus 6 absolute value of negative 24. All right. And of course, you should also check your solution in case they're extraneous solution, because we do have some domain issues sometimes. Or in particular, we have range issues. All right, so in this case right here, we need to isolate my absolute value. I'm not working on what's inside my absolute value. I want to get rid of everything outside my absolute value. I need to get rid of this guy right here. Some of you guys may be tempted to say add 3 to both sides. However, this is still a monomial. This is negative 3 times an object. So I need to divide both sides by negative 3. And if you divide by a negative, you need to change the direction of your absolute value inequality. So this becomes greater than or equal to 8. Okay? You need to swap your direction. Now I'm going to break it up. The absolute value is already isolated. It is by itself on one side. Of course, it contains some stuff, but I don't really care about that. But I'm going to break it up now. The positive is exactly the exact same. Exactly the exact same. I need to word that better. And then the negative over here, you have the exact same thing, but I'm already going to swap the direction for me, okay? Times negative 8. I'm already going to swap the direction. I multiply by negative 1, I'm already swapping the directions. Okay? So pay attention to that. Boom, boom, boom. And then now I solve. 2x is greater than or equal to 2. 2x is less than or equal to negative 14. I'm dividing by a positive 2 to both sides. So that's x is greater than 1, and x is less than or equal to negative 7. So now I try to graph this out. What does this look like? 0's over here, 1's over here, negative 7's over here. It's including because it's greater than or equal to and less than or equal to, so I put a closed circle in here. Now, x is greater than 1. That goes to the right side. So now I have the or symbol. And then x is less than or equal to negative 7. That's to the left side over here. So boom. So your solution is is the interval negative infinity to negative 7 brackets parentheses union brackets 1 to infinity. All right. So that's it for today. Take care. Bye.